Hey everyone, welcome back. In this video, we'll take a look at this sub-GHz radio collection from HackerBox. So if you've never heard of HackerBox, they put together these boxes that contain a collection of items related to making, breaking, and hacker culture in general. Each box has a theme of some kind, like the theme of this one is sub-GHz radio. And they almost all come with some electronic projects to build, usually a different microcontroller like an Arduino or an ESP32, as well as various other components and merch related to whatever the theme is. You can buy the boxes individually, but naturally you'd get the best deal if you subscribe and get them on a monthly basis. And in case you're wondering, they're not sponsoring this video, I just really like the product selection in most of their boxes. If you like my channel, then you're probably into microcontrollers and electronics too, so I imagine you'll like them as well. Anyway, let's open up this sub-GHz box and go over everything that's inside. So first we have this pin that says "So sexy it hurts," and it's got a little oscillator circuit diagram there. Just a little bit of nerd humor. Most of the boxes seem to have some kind of quirky little merch item like that. Then we have an FM receiver kit. So this is a soldering project. Basically to build your own FM radio. And it looks like a pretty easy project to build. The hardest part seems to be this little surface mount IC chip. So you'll just need to be careful when you're soldering that together. But otherwise, they're just through-hole components. Comes with a little, AA battery pack that you can solder on to supply power. Pretty simple. Let's look at that circuit board again. You see where the buttons go up here. You've got the seek buttons for changing the frequency, and you've got the volume buttons. I'm not actually sure what the PSW button is, but I'm sure if I go over their documentation, it'll cover all of that. Anyway, the idea behind this kit is that you build an FM receiver so that you can pick up FM radio waves. And it says that it operates between 76 and 108 megahertz, which is like the standard radio station range that you would pick up from, your local radio station. This device will pick those up. It has a little headphone jack so you can listen to it or plug it into speakers or the microphone plug in your laptop and record. So that's a pretty neat little device. And to go with that, they also include this FM transmitter kit. So this is another soldering project that lets you build a little radio transmitter. So you can broadcast your own radio station, basically. And I believe it operates in roughly the same range as this. So you can broadcast from this kit to this kit and basically make your own wireless transmission device. And it even comes with a little microphone. You can see there's a little potentiometer to tune. This one doesn't have any surface mount components, although I think it's going to be tricky to solder on the microphone because you're going to need to apply some wires to the microphone first to go through this. So that is kind of like a surface mount soldering job there. But everything else is through hole and it looks pretty easy. It has a picture on the back. This is a really old school circuit board too. It's not like the kind of circuit board you find in a lot of kits these days. I kind of like that though. It feels nostalgic. It reminds me of circuit boards I took apart when I was a kid. But yeah, it's got pictures to show you where all the components go. You might need to do a little bit of research to figure out which components are what. I think there's a few resistors in there. You'll need to make sure you use the right ones. And so on. I believe this wire is the antenna, so that's going to attach probably to that little TX hole right there. So yeah, that'll do the broadcasting. And these are basically like a little bug, right? Because if you use this little 9-volt power supply, which also comes in the kit, to power this, then you can drop this somewhere and send audio data to your receiver wirelessly. So you can just leave this somewhere to basically relay any audio over a radio transmission. But you can also broadcast your own radio station. Granted, it's going to be pretty low power, so you're not going to get a huge range out of it, but it'll still be neat to experiment with, and I don't know, maybe you can crank it up a little bit or use a longer antenna. So these kits kind of go with each other, although they can both be used separately. And then this next one, so this is really neat. This is maybe my favorite thing in this box. And this is a software-defined radio. They're usually called SDR devices. Obviously, this plugs into your computer, although they do include a little adapter that you can plug this into, and then plug this into your phone or any other device that uses micro USB, and also apply power to it in case you want to use an external power source. But on its own, you can just plug this right into your computer in the USB port, plug the antenna into this little antenna port here, and then you can start picking up radio waves over USB. And these things are crazy. You can do all kinds of stuff with this. So the software-defined portion of this means that you can set the radio parameters from software on the computer. And there's open source software you can use to do that, but you can also do it programmatically. Like you can write your own code to control what the radio picks up. And then you can pick up not just radio stations and, CB radios, walkie-talkie type devices, ham radios. You can pick up all kinds of radio transmissions, including digital transmissions and, things like key fob devices, like car remote devices and things like that. There's all kinds of wireless remote applications that you can pick up using this, and then you can experiment with decoding the information that you pick up. Yeah, these things are just a lot of fun. If you've never played with a SDR stick, I highly recommend it. Just exploring the radio waves is all kinds of fun. And then next, this is another little soldering kit. This kit contains 2 transceivers. So these are, see if I can zoom in, 433 megahertz transceivers. So each one is capable of sending or receiving, and as a pair, you can use them for wireless communication. They handle all of the protocol, like all the wireless protocol, and you just solder them on over this little SPI interface. So, as though these weren't cool enough, the kit also contains some Arduino Pro Micros. So it contains 2 Arduino Pro Micros that are intended to go with these. So these are cool because they've got the little micro USB port, meaning that you can plug these into a computer for programming, one, but also for transmitting data. So you'll see that they also come with these little circuit boards, which are meant to be kind of a tie-in so that you can attach the Arduino Pro Micro to the transmitter. So the idea here is that you'll solder on these header pins like this, and then you'll solder on those to this little circuit board here, like that, and then you'll solder on the little transceiver module to this, and then you get this little like stick device that you can plug into a computer. So now you can upload firmware using Arduino to this little chip, and it'll interact with the radio, and you can send and receive whatever you want. you can actually, because you can use the USB port here, you can communicate to a computer over serial from the Arduino and connect two computers wirelessly using these two kits. But of course you can load any firmware you want and do remote applications without using a computer. You still have access to the pins to some extent, and you can see which pins aren't being used for this. So you can also have access to those pins for digital I/O. Maybe you press a button and then you send something over the radio waves, or whatever application you want. So what's neat about all of these is that they do kind of all go together. Like this little SDR stick, you can pick up the wireless data that you're transmitting on these because it operates in the same range. This goes from like 20 megahertz up to, almost 2000 megahertz, I think. I'm not entirely sure. But it definitely covers this 433 megahertz range. So while you're sending data between these two devices, you can intercept it with this and either debug it, like as you're building something cool with these, just to make sure that you're sending the right data, and just to kind of be able to visualize and explore the radio waves. So these two kits definitely go together, but then this thing can also be used with the receiver, or probably more likely the transmitter. So as you're sending data between these two kits, like going from this transmitter to the receiver, you can also intercept that data. And if you're sending audio, like with this transmitter kit, you can actually listen to the audio on your computer using this stick. So to give you an idea of what you can do with this device, I'm going to plug it into a laptop and show you some software that interacts with it. Okay, so now I've got the SDR stick plugged into my laptop, and I've got the antenna right here. And the antenna has a magnet on the bottom, so you can stick it to a metal surface, and you're good to go. Now you just need some software to interact with the USB stick. So the software I'm using is called GQRX, and this is free and open source. It runs on Linux. I think it runs on Mac, maybe Windows. And this lets you basically play around with that software-defined radio. It lets you change the parameters, like the frequency range you're listening to and the different radio modes that you're picking up. So there are a variety of different radio modes that you can intercept with this, such as AM, or amplitude modulated radio, frequency modulated, or FM. You can pick up wide frequency modulated, and a few other forms of radio waves. I've got this set right now to narrow FM. I'm actually going to change that to wide FM. And so you can see here the width of the radio frequencies that we're picking up. And you can adjust that. And you can also move around where you're picking up. Right now we're at the low end of the spectrum at 24 megahertz. And this is measured in megahertz. So let's go ahead and adjust that. We're going to move forward. And now you can see, this graph up here has responded, where somewhere around 30.2, you see this small peak form. I don't know if maybe I can adjust this. Yeah. So you see around 30.2, it kind of peaks here. And this little waterfall plot down here is showing you a kind of a history of the data. So a new line is being added at the top every second or so. I'm not sure what rate it's set to. But yeah, you can see like over time how the radio waves change. You can see there's a lot of static out here. This is just noise. It's just radio static. But there are some like apparent patterns, like some peaks are forming in certain frequency bands, but it's really noticeable right around here. And it actually looks like there's two frequency bands that have some kind of response on them. So let's go in here, try to hone in on this one little peak and see if we can't listen to it. And when I say listen to it, I mean you can turn up the gain here and actually audibly listen to it. So let's do that. So it's a radio broadcast of some kind. It's a local radio broadcast. I am here in Central Texas, so these are all going to be local stations that I'm picking up. Now this is really low in the frequency range to be picking up, which is probably why it's so crappy here. Let's go up into the normal like radio station range and see what we can find there. So now we're getting into the typical radio station broadcast range. And this is also the range that the soldering kits that come with this HackerBox also will transmit and receive in. So this is like your standard radio station. Let's go over here. I already know that this is a local classical station, so I'm not going to play too much of it because I don't know what the copyright laws on this are. I think I'm okay as long as I only play like a tiny bit, so let's play that. So yeah, it's like crystal clear. And again, we're picking this up through that USB dongle plugged into my laptop, and now it's playing on my laptop. And this is all just using that GQRX application, but because it is a generic USB device, you can use other software to deal with these incoming radio waves. For instance, there's a Python library for dealing with SDR devices that lets you change all of these parameters, like the frequency range you're picking up and the different radio modes, and you can basically write Python scripts to search for different data by changing those parameters and to record or stream that data however you want. So you can save it to a file, you can stream it out to an HTTP server and make your own like internet radio relay. I'm not sure how legal that is if you're streaming other people's radio, but I'm sure that there are contexts where it is legal and there's interesting stuff that you can do there. And again, since you can pick up digital radio transmissions like key fobs and wireless radio devices, you can decrypt or decode, depending on what the data is being sent, you can decode that data and figure out what types of digital data are being sent over the radio waves. So that's an interesting feature of these little SDR devices. Beyond just, listening to your local radio stations, because I realize not everyone is interested in listening to the radio on their laptop, but there's way more you can do with these. So here's a local talk radio. I'll play a little bit of that.
Critical to the state of Alaska and the nation.
I'm not going to play too much because, I have no idea what they're saying right now. You can also pick up your local weather broadcasts. So this application actually lets you bookmark some things. I think I'm going to move myself for a second and show you what this looks like. So you can bookmark different settings to go back to them in case there's an interesting broadcast that you want to go back to. In this case, I've bookmarked weather, a local fire dispatch as well. I'll show you that here in a second. So here is the weather broadcast. It's broadcasting on 162.38. So now I'm going to turn up the gain and we can listen to the weather.
The Austin Flash Camp May Free Climate Summary for yesterday, January 10th, 2019.
So that's pretty cool. And then you can go over here to, say, the fire department. So this is a local fire department dispatch frequency, and basically you can hear when they say, like, we have an incident and blah, blah, blah. I don't know what all the codes mean, but you can listen to all of the broadcasts and tell when there's an event and when they're basically telling fire trucks to go to that event. So you can do some really interesting stuff. And you can pick up like ham radio broadcasts from like amateur radio people, as well as some strange, I believe, digital signals here. If anyone knows what I'm intercepting here, let me know in the comments. But I'll try to play this. I think this is a digital broadcast of some kind. It's some kind of data, because it sounds like it sounds like that, like old school dial-up, which makes me think it's definitely broadcasting some digital data. I have no idea what this is, but it would be a lot of fun to take this thing out and try to hunt down where the source of this broadcast is from and what it might be. Could be something interesting. It could be something dumb. Who knows? So yeah, those are just some of the things you can do with these software-defined radio sticks. They're a lot of fun to play with. This is kind of just scratching the surface. You can also pick up like flight navigation radio from airplanes overhead. You can pick up like sometimes police dispatch, depending on your locality, like what technology they use. So yeah, interesting stuff. You should definitely check it out, and it comes in this HackerBox, so that's very cool. So yeah, that is the sub-GHz radio HackerBox. That's their box number 0034. I'll leave a link in the description if you want to check this out for yourself. They make all kinds of boxes. They're really neat kits. Definitely a nice product selection. Their website has a PDF that has all kinds of information on each box, or each box has its own PDF. And they tell you how to use all the components, where to find more information on the different kits and parts. You should definitely check that out. So in a future video, probably my next video, I'll go ahead and solder this kit together and show you how to do wireless communication between these two Arduinos, and probably how to intercept it using this dongle. And then in another video, I'll probably solder these two together and show you how to make your own little radio broadcast and receiving setup. But that's it for this video. Go to the comments below. Let me know what you think about this HackerBox. Let me know if there are any of the other HackerBoxes that you'd like to see me check out on this channel. And until next time, bye!